Dear student, in this lecture we will discuss Hund rule. Hund rule basically tell us about the pairing of orbital by an electrons. Hund rule state that electron in orbitals of subshell prefer to remain unpaired. And secondly, Hund rule state that electron are paired in orbitals when half of the orbitals are filled with electrons having parallel parallel spins. These are the two main statements of Hund's rule. So if I conclude, Hund rule basically tell us about the preference of filling of orbital on the basis by electron on the basis of spin. Hund rule state that electrons usually fill prefer to remain unpaired in orbitals. In case if orbitals are filled, then the electron will be paired in only one condition when when the orbital of the subshell is filled with parallel spin electrons. So let me give some example. As you know that the p orbital of any kind of subshell have maximum number of 6 electron, and the p subshell has basically it has 6 electrons. So this means that p subshell have 3 orbitals, and every orbital have an ability to accommodate maximum number of 6 electrons, and these electrons can be occupied in a form of pair. So in order to get electron in a form of pair, according to Hund rule, first these orbital will be filled by electron with a parallel spin. When the electron with the parallel spin have filled the p orbital, then next 3 electron will be parallel, but they will be in opposite spin to the previously parallel electrons, like this. So in this way, the electrons will basically pair the inside the p orbital of an atom. So dear student, as you know that the trick of the electronic configuration, that we can use this trick, that first we can write that one s subshell, then we will write 2s, 2p subshell, then 3s, 3p, and 3d subshell, then 4s, 4p, 4d, 4f subshell. So in order to get a preference of energy for electron to fill the subshells, we will just draw a straight line like this, a vertical line like this, and on the basis of this vertical line, we basically conclude the increasing order of the energy for the electron to fill the subshells Okay, so electron will basically prefer to fill first one S subshell, then the electron will prefer to fill two S subshell, then it will fill two P subshell, then three S subshell, then three P subshell, then four S subshell, then three D subshell, then four P subshell, and then four D subshell, and then four F subshell, and so on. So basically, the filling of electron is on the basis of increase in energy of the orbital, and orbital energy is increasing from left to right from 1s orbital to the 4f, from 1s subshell to 4f subshell. So now, dear student, the maximum number of electron possible in S sub shell is 2. So we will write 2 anywhere where there is S subshell. So they will basically accommodate maximum number of 2 electron. Whereas we can write the maximum number of electron in S subshell by using a diagram like this. Electron will be in opposite spin, anti-parallel spin in the S subshell. The maximum number of electrons possible in P subshell is 6. So we will write 6 with every p subshell. The maximum number of electron the p shell subshell will accumulate 6, and as you know that p subshell is basically has 6 electrons, so every orbit can accommodate 2 electrons, so there will be 3 orbitals in p subshell. Please keep in mind that according to Hund's rule, initially parallel electron with parallel spin will occupy orbitals, and when they completed the parallel spins, then electron with opposite spin will be paired in the orbital like this. Similarly, different, as you know that D subshell have maximum number of 10 electrons. So in configuration, we will write 3d10, 4d10. So in this case, if we do electronic configuration for d orbital have 10 electrons, and every d shell have 10 electrons, and every orbital can accommodate maximum number of 2 electrons. So d shell will be consist of 5 orbitals, 1, 2, 3, 4, and 5. Initially, according to Hund's rule, these 5 orbitals will basically first occupy electron with a parallel spin like this, and then when the parallel spin is complete, then electron will be preferred to be in the form of a pair, and but the spin of the electron will be opposite the previous spin of the electrons like this. So in this way, d shell, the orbital of the d subshell are filled. In case of f subshell, F subshell have maximum number of electrons it's possible to accommodate by F subshell is 14. So this means that orbital in F subshell will be 7, because the maximum number of electron possible for orbital to be accommodated is 2. So there will be 7 orbitals in F subshell, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and 7. Initially, according to one rule, these orbital will first fill electron with parallel spin. And then these orbital will, in a form of pair, these orbital will fill the electron with anti-parallel spin like this. So in this way, dear student, electrons are paired inside the orbital of a shell. Dear student, please keep in mind that it is not necessary that first electron in F shell, P shell, or D shell, or S shell, the subshell, they basically fill the subshell with a spin up electron. It could fill the subshell, the orbital, or the orbital of the subshell could be spin by electron having a spin down state, or it could fill the electron by having a spin up state. But important point to notice here is that electron first prefer to fill the electron prefer to remain unpaired. So initially electron will fill the all orbitals present in the subshell, and when and these electrons must be parallel, and when they fill all the orbital of subshell, then anti-parallel electron, the electron with having opposite spin of the previously filled electron, will basically fill the orbitals, and they will be also parallel to each other. So in this way, the subshell of the atom are filled, or the orbital of the subshell of an atom are filled by the electrons. So now dear student, let do some electronic configuration for few elements in order to understand the Hund rules. So student, the first atom of the periodic element of the periodic table is hydrogen. An atomic number of hydrogen is 1. So the hydrogen atom will basically fill one s2 orbital, and one, since the hydrogen has one electron, so hydrogen will fill one s1 orbital. As you know that s subshell have only one orbit or one orbital, and it will fill this orbital by an electron either in spin up or in spin down state. So s one orbital will be filled by S subshell will be filled by electron with having a one orbital. Similarly, in case of electronic configuration for helium, as you know that helium atomic number of helium is 2. So the electronic configuration for helium atom will be element will be 1s2. So the s orbital will basically occupy 2 electron. One electron will be in spin up state. Sorry, let me make it in one color. One electron will be in spin up state, and whereas other electron will be in spin down state. So two opposite state electron will be present in orbital in with two opposite states. So this is for filling of 1s2 orbital. Similarly, 1s2 subshell. Similarly, for in next element of the periodic table is lithium. The atomic number of lithium is 3. So the electronic configuration for lithium will be 1s2, and so this means that s subshell 1s subshell have basically filled 2 electron, and next subshell is 2s. So one electron remaining, so 2s will occupy basically, or will fill its subshell will with 1 electron. So we can write it with a diagram that 1s 2 shell will be filled by 2 electron having opposite spin, and whereas 2s2 subshell is basically 2s1 for helium, so only there will be 1 electron. Electron could be either in spin up or spin down state, so we can write both. Either we can write this the electron in a spin up state or in a spin down state, so it doesn't matter. But the 2s1 shell will for a helium 2s2 shell for a helium atom will occupy only one subshell of helium atom will occupy only 1 electron in its orbit. Now in case of a fourth element of periodic table, which is beryllium, the atomic number of beryllium is 4. So beryllium will basically first fill one s2 subshell with 2 electron, and then 2 electron in beryllium atom will fill 2 s2 subshells. So in this way 4 electron will be completed in beryllium atom, and we can write this by a diagram like that. One s2 subshell of beryllium atom will basically fill its orbital by 2 electrons with opposite spin. Similarly, 2s2 subshell will be filled uh, by 2 electrons with opposite spins like this. So now, student, in case of boron, boron having an atomic number of 5, boron, the electronic configuration for boron will be 1s2, 2s2, and 2p. Since, as you know, that 1s and 1 2 have occupied 2 electrons of 4, so next shell is 2p, subshell is 2p, so 2p will occupy only remaining 1 electron. So electronic configuration for boron will be first, the diagram for boron will be first, boron will occupy 1s2 subshell, and in 1s2 boron will accommodate 2 electron with opposite spin. Next subshell for boron is 2s2 subshell, and in 2s2 subshell of the boron will basically occupy 2 electron with opposite spin. Similarly, next subshell for boron is P, and P subshell of boron can accommodate maximum number of 6 electron in it. So the P orbital of boron will basically have three p subshell of boron have 3 orbitals in it, and maximum number of electron possible in boron are 6. However, boron in p subshell have only 1 electron, so we can write 1 electron somewhere in any orbit of the boron. Please keep in mind that the that the we can write the energy of the orbital of the boron of the p subshell is same. Every orbit, this orbit or this orbital, every orbital have same energy, so we can write electron, the spin of electron anywhere in this orbit, an orbital. And secondly, it is not necessary that the electron present in orbital are in spin up state. They could be in spin down state also, so we can write them also in spin down state. So this is basically electronic configuration for boron. Now coming toward the electronic configuration of carbon, having atomic number 6. Now here we can basically apply Hund rule. The electronic configuration for carbon is 1s2, 2s2, 2p2. Since you know that 1s2 and 2s2 have 4 electrons, and the remaining 2 electron will fill 2 orbital of the carbon atom. So we can write them in a form of diagram that 1s2 of carbon atom will basically fill uh, uh, its s2 orbital with an electron with opposite spin. Similarly, next orbital, next shell in a subshell in boron atom is 2s2 subshell, and 2s2 subshell can also accommodate 2 electrons, so it will basically occupy 2 electrons in it. Next subshell in boron atom is basically p subshell, and p subshell can accommodate maximum number of 6 electrons. So the orbital of the p subshell can accommodate maximum number of 6 electron, and every orbital can accommodate maximum number of 2 orbital. Now question here is that the p orbital of the boron will accommodate only 2 electrons, because borons, the remaining electron in orbital, remaining electron in boron are two. So these electron will fill these orbitals in they will fill the orbital with a parallel spin, okay, like this. The spin uh, could be opposite, like spin down, but they will be parallel. So in this way, the orbital are initially filled by the electrons in energy levels, or by the electrons. So in simple word, in case if there are pair of electrons, suppose that we have a p subshell in any kind of atom, and the p subshell have maximum number of 6 electrons that can be accommodated by p subshell. So the orbital will initially, dear student, please keep in mind, will fill these orbital with electron having a parallel spin. So now these orbitals are filled by electron with a parallel spin. Then the remaining electron will fill these orbital, but the spin of this electron will be opposite to the previous spins of electron, like this. So in this way, electron will pair this orbital in the subshell of an atom. So dear students, this is all about Hund rules. So let me conclude the Hund rule. The Hund rule basically tell us about filling of orbital in subshell. Hund would state that electrons prefer to occupy or prefer to remain unpaired. In case if there is a possibility for electron to be paired, then they initially the subshell, or the orbital of subshells are initially filled with electron having parallel spins, and after that pairing of electrons take place. So this is all about the Hund rules. So thank you for watching this lecture.